Hello everyone. This is Dr. Captain K. Sujata, Professor of Mathematics, St. Joseph's College for Women, Autonomous, Visakhapatnam. In this session, I am going to discuss method of variation of parameters, part 2. Learning outcomes. After successful completion of this lesson, the student will be able to solve linear differential equations, and solve the linear equation of second order with variable coefficients with variable coefficient by using change of dependent variable when the part of complementary function, that is CF, is known. Solve the linear equation of second order with variable coefficients by using variation of parameters. In the previous session, we have discussed following definitions and some problems. Linear differential equations of order n. The linear equation of second order with variable coefficients can be solved by following methods. By the following methods, what are the methods? We are discussed already in the last lesson. Change of dependent variable when the part of complementary function is known. Next one, working rule to find the part of complementary function of linear equation with second degree equation with variable coefficients, that is d square y by dx square plus p into dy by dx plus qy is equal to 0 by the inspection method. Now coming to the method 2, variation of parameters. So in this lesson, we are going to discuss about the variation of parameters. So about the variation of parameters, what are the working rule? So working rule to find the general solution of d square y by dx square plus p into dy by dx plus qy is equal to r. Let it be this equation as 1 by the method of variation of parameters. In case the given equation is not in the standard form, reduce into the first standard form. That is the first step, right? So these are the steps to find the to solve the differential equation by using the variation of parameters. First step is, in case the given equation is not in the standard form, reduce it in the standard form. Now coming to the second step is, find the solution of the given equation d square y by dx square plus p into dy by dx plus qy is equal to 0. If it is equal to 0, r is equal to r, right? But LHS should be in the form of our linear equation of second degree with variable coefficients, right? Let its solution be. So this is a solution of the general solution of the differential equation. Y is equal to c1 into u of x plus c2 into v of x, which is a complementary function of equation 1. So this becomes a complementary function of equation 1, right? Now after that, after getting the complementary function, so we have to go to the particular integral, that is a pi. Let the particular integral of equation 1, that is, let it be yp is equal to au plus bv, where a and b are the functions of x, right? So after getting the particular integral, next we have to find out find u into dv by dx minus v into du by dx. Next step is, we have to find out the a and b values by using the formulae. A is equal to integral of minus vr into dx by uv dash minus vu dash, and b value is ur dx by integral of ur dx by uv dash minus vu dash, right? Now coming to the last step is the general solution of 1 is, finally we are going to write the general solution as y is equal to c1 into u of x plus c2 into v of x plus au plus bv. Now, there is a note, in order to solve linear equation of second order, d square y by dx square plus p into dy by dx plus q into y is equal to r, proceed as follows. So we have to follow these two steps, these two conditions. If the part of complementary function is given, if the part of complement CF is given, or suppose if it is given, then I can take directly that one. Otherwise, known by inspection method, we know, no, in the last session. So last lesson we have gone through all these methods. If it is a complementary function is known, then we can find out we can proceed further. Otherwise, if we don't know the complementary function, then we can follow the inspection method to find out the complementary function. Then apply the method of change of dependent variables, right? Then after that, second condition is if the method is mentioned. So method if it is mentioned in the given problem, then the only apply the method of variation of parameters. Otherwise, you can follow this method. If the method is mentioned under variation of parameters is solve the differential equation by using the variation of parameters. If they are given ala iste, then compulsory you have to apply this method. You have to follow the variation of parameters method. Now coming to the problem. See here problems are there. Solve d square plus a square. This is a differential equation is given. D square plus a square into y is equal to tan ax by the method of variation of parameters. Right. So here this variation of parameters are very important. The examination point of view. Now given equation is this one. D square plus a square into y is equal to tan ax. Let it be the given equation as equation 1, right? Now after that, consider the given function LHS. This part, let it be f of d, functional value. In terms of the differential operator, f of d is equal to d square plus a square. Now after that, we have to going to find out the auxiliary function, auxiliary equation of f of m is equal to 0. So we are going to find out the auxiliary equation of this, that is f of m is equal to 0, means in place of d it is substitute m square plus a square is equal to 0. Now from this we will get the factors of factors of this equation, that is the m plus or minus ai. M value is plus or minus ai, right? So using if we get the factors, if we get the values of m like this, then directly we can find out we can substitute this value in this yc. That is why what we call auxiliary function, we will get it. In the auxiliary function, just like, see, I will show again the method. See, what are the methods we apply? Working rule. See, in case, first, what is the first working rule for the variation of parameters? First step, what we have to do? In case if it is not in the standard form lo lekapote, then convert into the standard form. Standard form means this is a form. This is a form. If it is not given the standard form, write down in case it is given equation is not in the standard form, reduce into the standard form, right? Then tarvata em chestamu, find the solution of this equation. So let it be the r value 0 aina manam we can find out the solution. That's why we have to take an r value 0. Then we first what we want to find out which is a complementary function. So using this, first find out the complementary function. Complementary function vachaka, next go to the particular integral. Complementary function find out chesaka particular integral kellali. Particular integral vachaka, then particular integral formula is this is one. Complement, after getting complementary function, ఆ factors c1 c2 తీసుకుని complementary format ఇలా రాస్తాం. అలాగే particular integral ఇలా రాస్తాం. yp is equal to au plus bv, right? So using these two, then you should find out the value of this u into dv by dx minus v into dv du by dx, right? No, after that, next change chestam a, and for applying the variation of parameters, we need to calculate a and b values. So a value, a formula is this one, b formula is this one. So after getting a and b, then you can write down the general solution. So same steps we applied here. So after getting this, then go to the complementary function yc. Complementary function ni yc antam. So c1 cos ax plus c2 sin ax. So here this is m is equal plus or minus a kada. So here we have to take the a, this is a value in the form of the imaginary factors. So we have to take here that this is in the form of, we should write the complementary function like this using the formula, right? In the same way, using the complementary function, then write down the not using, then go to the particular integral. So what is the particular integral? Yp is equal to a into cos ax plus b into sin ax. Let it be equation 2, where a and b are the functions of x. Then u is equal to, here u from the complementary function మన వర్కింగ్ రూల్ ఇచ్చాం కదా, దాని నుంచి కంపేర్ చేస్తే u వాల్యూ cos ax అవుతుంది, v వాల్యూ sin ax అవుతుంది. అండ్ r is equal to from the given equation tan ax అన్నమాట. సో by the method of variation of parameters, then we have the formula is given in the working rule. uv dash, you have to find out uv dash minus vu dash is equal to, so substitute what is a v dash. Already we have written what is u, what is v. From that write down the v dash, from that write down the u dash. So simplify that, we will get this is the value is uv dash minus vu dash value is a cos square ax plus a sin square ax. Let it be. So but cos square ax plus sin square ax value is 1. If we take the common as a common తీసుకుంటే cos square ax plus sin square ax system, that is the value is 1. So finally this value is a. Okay, then go to the find out a formula already we are given in the working rule. So take that a value, a formula, now substitute the known values here, integrate, simplify that, we'll get the a value is, this is the a value. So integrate, you have to further, you have to thorough with the integration. What are the integral formulas? What is the integral of cos x, integral of sin x, integral of tan x, integral of secant x? What are the values? So if it is sin square x, ax is given. So how to find out the integral of sin square x? So every integral formula you should thorough, then you should know, then easily you can solve the a as well as a b. This is a b formula. B is equal to integral of u capital R dx by uv dash minus vu dash, right? So using this formula, then find out the b value also. So we got b value. So after getting after getting u and v, then write down the particular integral yp. Yp is equal to a cos ax plus b sin ax. In place of a and b, substitute these values. After getting yp particular integral, then write down the general solution. What is the formula for the general solution? Y is equal to yc plus yp. So what is a yc? Already we got it using the complementary function. No particular integral, using the particular integral we got yp. Then substitute those two values, we will get the, finally we will get the general solution. This is the first problem. Coming to the second one. What is the second problem? Solve. What is the second problem here? This is the equation is given. Solve. This is a general differential equation will be given by the method of variation of parameters, right? So x minus 1 into d square minus xd plus 1 into y is equal to x minus 1 whole square, right? No, write down the d, this is a differential operator kada. So generally d is nothing but dy by dx. So substitute d as d square y by dx square, and d square as d as dy by dx, this one. Now here standard formula లేదు కాబట్టి we are converting into the standard form. ఎందుకంటే కోఎఫిషియంట్ ఆఫ్ డి స్క్వేర్ వై బై డిఎక్స్ స్క్వేర్ ఇస్ యూనిటీ, ఒకటి వన్నే ఉండాలి. కానీ ఇక్కడ ఎక్స్ మైనస్ వన్ ఉంది కాబట్టి ఎక్స్ మైనస్ వన్తో త్రూ అవుట్ ఈక్వేషన్ డివైడ్ చేస్తాం. డివైడ్ చేస్తే we will get this equation. So clearly this is in the form of the standard form. Linear equation of second order with variable coefficients, right? So that is d square y by dx square plus p into dy by dx plus py d square y by dx square plus py into dy by dx plus q is equal to r. That is a general equation, general form. So దాంతో దీన్ని కంపేర్ చేస్తే then we'll get this, ఇంకా సింప్లిఫై చేసాము. This is a final y by x minus 1 is equal to 0. అంటే this is second equation, అంటే r వాల్యూ 0 తీసుకుని చేస్తున్నాం, right? So d square y by dx square minus x by same. Only thing is here we have substituted r value as 0. Now generally r value here x minus, from this we will substitute r value this one. No, for finding the complementary function or particular integral and all, so we have to take R value with this equation. This is a general form we have taken. With this equation, we are going to find out the complementary function. So if it is a complement function is known, then directly we can take. Otherwise, we have to follow the inspection method. So here we have followed inspection method. So first one inspection method we applied, clearly this value we got it 0. So here for this particular using that inspection method, so complementary function is y is equal to e power x. Already these using the inspection method, all the complementary function values we are discussed in the last lesson. So using that we got y is equal to e power x. Similarly, using the second one, so another using the another inspection method, then find out the this is also satisfied by the inspection method, this value is also satisfied. So from this we got the complementary function is x. So CF is y is equal to x is a solution of 2. So using these two we can write down the yc. Using these two we can write down the yc formula is e1 into u plus e2 into v, right? U is equal to e power x, v is equal to x, right? Now after getting the yc, that is a complementary function known, after getting that, then go to the particular integral of equation 1. Further, for getting the complementary function, we have to use the equation 2. For getting the particular integral, we have to use the equation 1, right? So particular integral of 1 can be written as yp is equal to a into e power x plus b into x, right? AU plus BV. U is e power x, BV is x, right? Now where A and B are functions of x, right? U is equal to e power x, V is equal to x, and R is equal to x minus 1, right? Now by the method of variation of parameters, we have the formula is there. What is the formula? UV dash minus VU dash, right? So from that we got this is the value e power x into 1 minus x. So after getting the using the variation of parameter, that for value we got it uv dash minus e dash. After getting that value, then go to the a, capital A. We know capital A value is this, and formula is this, and B is formula is this. Then find out the capital A using this integration. Similarly, capital E we find out using this integration. Then we'll get B as minus x and A as minus of 1 plus x into e power minus x. Using these two values, then find out the particular integral yp, that is yc plus yp is the particular integral. So the particular integral, that is yp. Now after getting yp, already we got yc, then go to the general solution of 1 is yc plus yp, right? So this is a general solution of the equation 1, right? No, this is the second problem is completed. Coming to the third one, this is another model that is solve d square minus 2d into y is equal to, this is similar to the first problem, is equal to e power x into sin x by the method of variation of parameters, right? Take the given equation, take it as a, in this d square minus 2d, take it as a functional value f of d. Now from that you find out the, because you will easily you will get the factors from this. So if you will not get the factors, then go to the previous method. Second problem is different. See here again I will show. See this is the second problem. Here what they have given x minus 1 whole square into d square. So this is the second one. So in this we converted into the standard form. So we are unable to find out the factors for this. So complementary function will not get directly here. So that's why we have applied the inspection method. Whereas in the third problem, what they are given, this is the third problem. Directly we will get the, from the auxiliary equation, we will get the complementary values. Complementary function yc. So find out the auxiliary equation of given functional value. So from that we'll get the factors of factors of m and m values. This is because second degree equation kada. So expression kapatti we will get the two values. From that easily can write down the yc, that is c into e power mx plus e2 into, using this e power mx plus e2 into e power mx. So one m value is 0, another m value is 2. So according to that, we'll get the yc value. So after getting yc, then go to the particular integral. That is a yp is a into this first value, a into u plus b into v, right? U is e power 0x means 1, b is e power 2x, right? So this is the equation 2. After getting the particular integral yp, then find out the a and b value. For getting the a and b values, we have to find out uv dash minus vu dash. So where a and b are the functions of x. Here u is equal to 1, v is equal to e power 2x, then r is equal to u power x into sine x, right? Now coming to the next one, then find out by the method of variation of parameters, find out uv dash minus vu dash. So we'll get this value. So after getting uv dash minus vu dash, so what we have to do, ఎందుకు అది కడుతున్నాము, ఎందుకంటే in a we need in the denominator this is a value only. So that's why first we find out separately, find out this value. Now substitute directly this value in for finding the value of capital A, right? So this is a formula for capital A. Now substitute this value here, we will get this. Now integrate, simplify, then we'll get the capital A value is this one. You have to thorough with the integration. So all the integral values, see here, e power x into sin ax, this is a uv formula. You should apply the integral of e power x into sin x means uv formula you should apply. From that so we will get the integral value here, right? So finally what we got it here, 1 by 4 into e power x into cos x minus sin x, right? Then after that coming to the b formula, b is equal to integral of ur dx by uv dash minus vu dash. In both the cases we need this term, this value. That's why initially first of all find out this value, then substitute in a and b. So integrate a and b here, then we will get here simply see we integrate it here also uv formula you should apply. Otherwise direct we have in the intermediate integral of e power x into sin x formula is there. Directly we can, if you remember that formula, you can substitute that formula only applied here. Otherwise you can apply the uv formula here. You can apply the v formula. So integrate, simplify this b value, we got it this one. Okay, so after getting a and b, then go to the particular integral yp, a plus b into au plus bv. Yp is au plus bv. So we got a, substitute a and substitute b, simplify, we'll get yp. So after getting yp, so already we got yc. After getting yp also, then substitute in general solution. So write down the general solution as y is equal to yc plus yp, right? So this is a general solution. Now coming to the next one. Next problem is similar to the previous one. Solve d square plus a square into y is equal to secant ax by the method of variation of parameters, right? Now take the given equation, given function, this function as a f of d. Now after that find out the this we call it as auxiliary equation. From this you can write down the auxiliary equation of f of m is equal to 0. Then find out the factors of m plus r minus ai. Then yc can be written as c1 into cos ax plus c2 into sin ax, right? After getting yc, then write down the yp, cos ax plus sin ax, where a and b are functions of x. U is equal to cos ax, v is equal to sin ax, r is equal to secant ax, right? Now after writing the u and v, then go to the uv dash minus vu dash by the method of variation of parameters. So this value we got a, right? Now then find out the capital A value, then find out the capital A value. So here we can up is integration. So integral of sin ax into secant ax by a dx. So minus a is a constant, no? So minus 1 by integral of sin cos ax can be written as 1, secant ax can be written as 1 by cos ax. So sin ax by cos ax is nothing but tan ax. Tan ax. So integral of tan ax is log of so how to integrate log of secant ax into 1 by a. Integral of tan ax is log of secant ax into derivative of the inner part, that is a. So we have to write in integration 1 by a. So simplify that, we'll get the a value is this one. right? In the same way, B value, this is a formula for the B. So B value, we got it x by A. After getting A and B, then write down the particular integral yp, A cos AX plus B sin AX, substitute A and B values here, and A cos AX is U, sin AX is V. Then write down the general solution is y is equal to yc plus yp. So this is a general solution. Okay. So we have discussed 4 problems till now. Now coming to the 5th problem, this is a different one when compared to the other 4 problems, right? And now what is a problem is given. Solve x minus 1 into d square y by dx square plus x into dy by dx minus y is this one. Okay. Now what is the condition is given, x is in between 0 and 1. 0 and 1 not in the boundary value, not in the boundary point, they are not boundary points, so strictly less than x is strictly less than 1. Okay. And given that complementary functions are given, y is equal to x and y is equal to e power x, ante u is equal to x is given, v is equal to e power x directly given, are linearly independent solutions of the homogeneous equation corresponding to the given equation, right? So uv values are given, no need to find out uv values, just find out here using the given differential equation. First of all, write down the standard form, that is a coefficient of d square y by d square should be 1. ఒకటే 1 ఉండాలి కాబట్టి దీన్ని throughout equation x minus 1 తో divide చేయండి. That is the first step. Then after that u value we have x, that is directly given. V value is e power x. So after having the v value, u value and v value, then write down the yc, right? So after writing the yc, so yc rasesam, right? Yc tarvata I have to go to the particular integral yp. What is the formula? Ax plus au plus bv. So u value, v value substitute change, particular yp value we got it. Now after getting the yp, then go to the uv dash minus vu dash. Ante enti u kavali, u is equal to x, v is equal to e power x, r is equal to 2 into ఇది r అంటే x minus 1 తో డివైడ్ చేసేస్తాం కదా. సో 2 into x minus 1 into e power minus x, right? Then after getting after writing uv and r, then you find out this value by the method of variation of parameters. We need this value uv dash. For getting a and b compulsory we need this value uv dash minus vu dash. Value ఎంత వచ్చింది? e power x into x minus 1. Okay. Now after getting this value, then go to the a, capital A. Capital A formula is this one. Now substitute known values here. So we'll get the capital A value is this one. Similarly, B value, capital B value, if I find out, we'll get simplify, apply integration, simplify it. We'll get the capital B value is this one, right? So after getting A and B, then go write down the yp. Then write down the yp. Now we know yc and we know yp. Then write down the general solution is y is equal to yc plus yp. This is a general solution. Okay. So with this, in this session, problems are over. So in this session, what we have discussed, we have discussed the following about the main thing is variation of parameters. Working rule to find the general solution of this thing by the method of variation of parameters. In case the given equation is not in the standard form, reduce into the standard form, right? Now find the solution of so this one, that is, let's its solution be, first one, y is equal to c1u plus c2. That is this is a yp, this is a yc, this is a yc, that is y is equal to c1, yc is equal to c1u plus c2v, right? Which is a complementary function of equation 1, right? Now let the particular integral of equation 1 be, equation 1 we can take this one also, no problem. Then yp is equal to au plus bv. So after getting yc, this is a yc, this is a yp. After getting yp and yc, then find out the uv dash minus vu dash. For why we are finding vu dash, uv dash minus ve dash endukante, for getting capital A and B values, these are the formula for A and B kada. ఇందులో ఈ డినామినేటర్ లో uv dash minus vu dash ఉన్నాయి కాబట్టి first you find out uv dash minus ve dash, then write down the general solution. Okay. Thank you. No, the next session, in the next lesson, we are going to discuss further solutions of the differential equations. Thank you.